Hello and welcome to another free code session. My name is Jason Bach and I'm going to do a recording quick before I do a workout this afternoon. I didn't get what I felt like a lot accomplished at work today, so I want to do something where I feel like I actually accomplished something, and that's what this is going to be. So this is essentially, I'm taking all the things that I did on the range type and system and obsoleting them and moving them to my range type, the one in Spackle. So hopefully I feel like I've actually accomplished something once I've done all these things. So the first things we're going to do is we're going to say, I'm going to wait to obsolete all these. Okay. Because I want to use these to copy here. And so the first thing we're going to do is add partition to our range type. So if we come here and we go to range extensions, there should be a, whoops. No. Fine. Partition. And that has all that wonderful code in there, but we don't care about that. We just want to move that to ours. Okay. So we're going to take this, copy it, and we're going to move to range here. And I believe we do not have a partition here. I'm almost positive. HI. Yeah. Okay. Except we're not going to make this this. We're going to do that. We're going to say a range. No. Our range of T. Which brings up an interesting conundrum. Okay. I've been, and this, this is something I've been starting to ruminate on, which is if I do this as a number, is there a way to say add one or increment? We can try. I think there, yeah, let's actually do this. Instead of it saying where T is I comparable, I wonder if I said I number of T. Okay. And then I just comment that out. Okay. So we're still equatable. And I don't think I number of T has the equatable. I'm not sure. Because that's not part of our, we're not saying range is a number. We're saying range implements number, but T has to be a number. And the reason why I say this is because I wonder if we can do some magic here. Let's say, wait, what are you saying? No, that's totally wrong. This dot start, not that, is equal to this dot end, this. Oh, they're not. That is an argument exception, that I can say. This is not, I would say this is almost a not supported, which might change some stuff, but that's fine. Because we don't say you can't have a range of 0. Okay. And I should also put in my things here that it's saying, yeah, we do inclusive on purpose. So let's just change all the to this dot this dot start, and then this dot end. Okay. Why are you not supported? Which would not take this. Okay. Number of ranges. Well, where do we get that from? I'm such a... Okay. This, we wouldn't care about, we would never do this because there was never, we'll never reverse. Ranges always go from a smaller to a larger, or at least they're equal. And so actually in this case, there's no reason to do this. Actually, I mean, it was cute that I found that, but we don't need to do this because we are always doing n being at least equal to or greater than start. Okay, so we can get rid of that. Yeah, fine. We'll include you. Okay. Create builder. That we're doing this as a slight optimization because what we're saying here is we want you to be, I wonder, is there like a I integer base 2 format? Defines an integer type that is represented in a base 2 format. I don't know what that means. I have no clue what that means. What is ibinary integer? Does int implement ibinary integer? Defines a number type. Yeah, that's great. Okay, maybe this is being a little bit too cute, but it would be nice if we actually, because what I'm saying here is it would be nice if we could say, give me an int, give me a byte, give me, whatever you want. This could be a range of bytes. This could be a range of integers. This could be a range of, saying it's a range of doubles would seem a little weird. And so that's why I'm wondering if I did like var x is equal to 3, and then I said, no, go away. So it's a binary integer. It has a min-max value. It's a signed number. Okay. But it does not, well, it could be that it implements a number from God knows where else in here. You know what I mean? I think one of the things that this whole generic math stuff, it's been great, but I think there's definitely going to be some work done because it's just like, you're just swamped with interfaces. You know what I mean? And what's the right one to pick where is a really good question at times. I'm going to say binary because if I say number of ranges here dot, well, it doesn't really help now, does it? It just gives you like a 4 that doesn't actually say what you are. Maybe this is being too cute. You know what I mean? But it would be nice to say where t is an int. And we've said this, that it could be a range because all we cared about was that it was comparable. A range of comparable things. But how do you partition something with any t type? It would also be good if we could do this, but like in this case, well, let's just keep going. I think the thing that falls apart here is that's still a t. But now you get into this, like how do you actually number of ranges? That you really can't, you can't do a loop on, t dot 0? I don't know. Okay, maybe remainder is saying if it's greater than t dot 0, then could it be t dot 1? Otherwise t dot 0. So wait a minute, we're doing a partition range here. But we're actually making this a system range, which is not what we want. And this could start to get into some really bad things. And why would we reverse? Yeah, we're doing, this is an immutable. Okay, I don't know where that mutable array. Yeah. I would say if they're the start and the end, that's not necessarily bad. Like here you would just say return immutable array.empty, but you can't. Yeah. There. You just don't return anything. Well, you just say we don't have anything to give you. Okay. Number of ranges. Okay. Here though, this is where it gets a little odd. But we don't ever need to, reverse. So there's no reason for us to even worry about this. Okay, because we're always going to go from smaller to larger. I'm worried about this a little bit because this was, in effect, even if I didn't quite realize it, this was using an exclusive. But where's k coming in here? That's the start value. because the end, so this is saying you're going to start here. I wish it would just stop. I don't need that. So, but we say like 1 to 0 to 5, because we're actually saying 0 to 4. And then we need to say 5 to 10, but we're really saying 5 to 9. So the K is the start value here, but we don't need, like we need to say new range of T. We're saying that's the start. Okay. And then this would be minus T1. And I believe that's correct because we're saying K plus the minimum partition range size plus remainders. Hold on, let me come back to that. This would actually be minus T minus 1. Okay. If the remainder is greater than T, wait, what was that, 0? Yeah, T0, then we say remainder minus minus, otherwise we say T dot 0. Ranges, we add a partition range. Ranges are a range of T. That goes away, that goes away. So, well, we don't have any compiler errors anymore. But does it actually work? I don't know. So, I mean, we do have tests. So that's the beauty of tests. One of the very beautiful things about tests is that we can say partition. Okay. And here you notice that the exclusive end is that. And this is saying it's an even distribution. So we should say we're saying from 0 to 999, which for us we'd want to say 0 to 999 because we have 1,000 elements we want to distribute over a partition of 4. Okay. So if we said we had 1,000, that would be 999 minus this. Is the range difference? Yeah. Is the range difference less than the number of ranges? So in other words, you're saying I want to go from like 0, 1, 2. So it's 2 minus 0, but you really need to say plus T dot 1. Okay. Because that's your actual difference. You have 3 here. If you have 0 to 2, 2 is inclusive, so you need to say 0, 1, 2. So it'd be 2 minus 0, 0 plus 1 is 3. Okay. Math, Jason. Okay. So that's the range difference. The minimal partition range size is a range difference divided. So if you say 1,000 divided by 4, that's 250. That's the minimal range size. Okay. And so here, what we're going to do is say the remainder is the range difference, which would be 1,000 mod that, which would give you, in our case, would be 0. Okay. So we don't have a remainder. So if we fall through this, we're going to say from 0 to the number of ranges, adding plus that. We now say the partition range is the one that we're creating. We're going to start from 0 because that's the start. And we need to go up to 250. So we'd say, we want to say 0 to 249. Right? And so we're going to say 0 plus the minimum partition range size is 250, right? Because yes. So we'd say 0 plus 250. The remainder is 0, so we're going to say 0. But we need to minus 1 because that gets us to 249. Okay. Now the end here plus 1. Okay, because we just did 0 to, we got 250. We realize the remainder is going to be 0, so we just do a 0. And then we minus. I'm not sure why you say 1 here, though. Partition range, if the remainder is greater than 0, you just add 1? That just seems weird. The remainder is the, oh, that's Right. I think that's what happens. Okay. Yeah. I think what you're doing is you're adding on like a little bit if you have a remainder. And then every time you go through this, you're subtracting from the remainder until you have no more. And then you wouldn't keep adding it on. I think that's what that's doing. And in this case, we don't have it, so we don't see it. So we get 250, 249. That would be 249. We do 250. We don't have a remainder, so we don't do anything. The remainder still stays 0. We add our new range, and we say range is 2 immutable. Okay? And we keep going through this. Let's just, because why not? Yeah, check equality, check two string. You notice that this all works. You know, the funny thing is that this can't actually determine what the type of it is. Even though I'm telling you it's T is a int, it can't say, it can't infer that, which makes sense. Okay, fine. So let's do a partition here. Okay. And so we have range extensions. We're going to say partition with an even distribution. Okay. And so we say our range is a new range of int that starts at 0 and goes to 999, inclusive. Okay. And now we're going to say we should have, the end should be 249. The start should be, yeah, go away, 50. This should be 499. This, yeah, go away, go away. Yeah, I like that it does it. It just, it takes a little bit to get used to. Okay, this should be 749. This should be 750, and this should be 999. Let's see how bad this blows up. Shows you the confidence I have in my coding. So all the start values should be the same. The end value should just be -1 all the time from the other tests. Passes. Let's see if I'm a lucky dog. Yeah, we don't care about ascending ranges and descending ranges, although I will do this because I want to see if those also follow, you know, just do another test on that. So you come here, and let's see what happens when we have an uneven distribution. Again, I think this will just completely fall on its face, okay? So this has to be 49999. 49999. I mean, it's great. Again, I said it before. It's great that it picks this up. It would be even greater if it was just a little quicker. But hey, something about beggars and choosers. Okay, so what I said last time is that these are just one less. So this should be 43. This should be 86. 29. No, 29. Jay said math it. 72. 15. 58, 57. And then 4999. Again, I do not believe this is going to work. I can't imagine this just working out of the gate. So it's going to have an issue here. Something with the remainders and stuff is going to fail. And it passes. Okay. But hold on to your butts. I'm just curious if I say bytes. And so let's just do, of course, this isn't going to work because it's going to say that's too big. Okay. So let's say 99. Okay. And so this would be 49, 50, 99, 100, 149, 150, 199. Wait a minute. No, that's completely wrong. Let's just make this 1 because that's what I guess I was assuming. But that should, I think I did the math right. That should work. Wow. This is actually the first time that I've really done something with generic math and the interfaces. And this really feels powerful because I've genericized this algorithm so that it doesn't care what type you put in. You can put in bytes, you can put in ints, as long as it implements as you see up here, I binary integer, that's all that matters. And we took off I comparable because is there still a compare to? I believe we still have a compare to. Oh no, that's just saying T needed to be I comparable. So somewhere in here we were, I guess, doing like a compare to somewhere. Yeah, which is kind of odd. So end must have, if we F12 into this somewhere, yeah. I mean, sure, but end is a T. And so I'm guessing somewhere in the binary integer, it's got to, and of course where. I would not say it's the shift operators. I would say it's probably in binary number. Number? Comparable. There you go. So it does implement. This is cool. Okay, I'm not done yet. I'm definitely not done yet. I'm still got some extra tests to put in, but I'm going to stop here for just right now and do some other stuff. But yeah, this made me feel like I conquered something today, and it's a little bit more learning about these static abstract members and interfaces, but more about the interfaces themselves and picking the right thing. That I don't have to do this anymore because it still is, but it's now doing it through a much more powerful interface of what we really want to do with ranges, which is handle binary numbers. So if you have a binary number, which I'm assuming means integer. I know the interface here says defines an integer type that is represented in a base 2 format. So 0 and 1, you wouldn't have like I float. Is there like an I floating point? Yeah. Defines a floating point number. So there could be a whole talk on these things and saying what's there. Maybe I'll do that. Yeah, this gets really, really deep in a hurry. But again, I find this to be really cool because all this stuff just works up here. None of it changed, but the intent of what I want to do and the flexibility and extensibility now is so much better. This is, I was kind of assuming that T was an int. And in this case, I don't have to do that. I actually can say it can be anything you want. Now, there was one thing here before we go that said something about conversion from system range or range of int. Can that be enforced at compile time? Because a system range, the start and the ends, they're indexes. But indexes can be converted to ints because there's a explicit conversion between an int to an index, and I think an index to an int. Because there's the value there. Either way, we could convert a system range to a range int, but that would mean that you are doing a range of int. You couldn't just say arbitrarily any range type because it may not fit. But I think either we would do this as a conversion, or we'd have a static method that would say create or something like that, given a range, and then we say we return a range of int, and that would be fine. That'd be okay. So I don't think we've, no pun intended, constrained ourselves in a bad way. So this has been fun. This has actually been really cool, and I hope to continue doing this because it makes my range type, I think, not more powerful than the range, because again, the range and index types that are in .NET are meant specifically for ranges and indices in arrays or collection types. They're not meant for just an arbitrary range type, which this is, and this makes it more, gives it more gusto for what it can do and not just be essentially an int type. Cool. All right, I'm going to stop here. Thank you all for watching. Leave comments and questions below. See you in the next episode.